Consider the following system of equations. Now, let us turn this system into a matrix that is an augmented form. And I believe that a couple of videos back, we discussed how to solve the system using augmented matrices. So let me begin that process. Now here is where I will slam on the brakes, because right now, since we have a diagonal of ones and this triangle of zeros beneath, that is called Gaussian form, where you have a diagonal of ones and below it you have a bunch of zeros. The content above the diagonal, we don't care about. I just need a diagonal of ones with zeros underneath. If you have that, we have Gaussian. And Gaussian is really good because if you look at this, you know we're trying to find x, y, and z. Well, this is 0x, 0y, 1z equals -2. So just by looking at this form here, we can conclude that z equals -2. I have 0x plus 1y plus 0z equals 1. So that basically tells us that y equals 1. 1x, I'll write this down. We have 1x minus 3y plus 3z equals -4. But then what you can do is take the values of y and z that you found and you can plug them in. So this would be x minus 3 times y, which is 1, plus 3 times z, which is -2 equals 4. Solve that and you'll discover that x should be 5 for x. And so that means that x is 5, y is 1, and z is -2. And that is how you can solve a system using Gauss. But what's the difference between Gauss and Gauss-Jordan? Well, Gauss-Jordan does not stop here. Gauss-Jordan does these thingies a little bit more. So let's continue here with Gauss-Jordan. So looking at this system here, this is what we call Gauss-Jordan, because we have the diagonal of ones, and then we have a trio or a triangle of zeros, not only below, but also above. And so this is what we call Gaussian or just Gauss-Jordan elimination. So they basically do the same thing. It's just that Gauss, it stops a little early and it goes back to this style of solving, whereas Gauss-Jordan plays with matrices all the way to the end. And I prefer Gauss-Jordan because you might as well finish what you start. Although sometimes it's easier to stop at Gauss. So they have their pros and cons. If there's a lot of fractions, maybe you want to stop at Gauss. But if the numbers are playing nicely, go all the way to the end to Gauss-Jordan, because this vector here, or this column, that column tells you your x, y, and z values. So that x is 5, y is 1, and z is -2, which is in agreement with what we had just a moment ago. So a few quick comments here before I let you go. So we solved the system of equations, and we did it a couple of different ways. First, we did Gaussian elimination, and then we extended it to Gauss-Jordan elimination. So both of these methods require that you take your system of equations and you rewrite it into an augmented matrix, where on this side you have the coefficients from the system, and then this column constitutes what the equations equaled individually. Now, what we did here, all of these individual steps, they are called elementary row operations. And we perform elementary row operations upon our augmented matrix until our augmented matrix looks like this. This is what we call Row-Echelon form. And that's what Gaussian elimination tells you to do. Gaussian elimination says, hey, take your augmented matrix and perform elementary row operations upon it until it looks like this, where you have a diagonal of ones, and beneath that diagonal of ones, you have a triangle of zeros. The content above, we don't care. I just need ones along the diagonal and one trio of zeros. And then when you get that, you'll have to do a little bit of substitution to get the other variables, because Z or C or whatever letter this represents will have been given to you. Now, if you do a few more elementary row operations, your row echelon will become reduced row echelon. You see the difference? Where row echelon has the diagonal of ones, but only one triangle of zeros beneath it. Reduced row echelon has the diagonal of ones, it has the triangle of zeros beneath it, but it also has a triangle of zeros above it. And that's convenient because reduced row echelon spits out the answers immediately without having to do a little bit of baby algebra thereafter. So whichever method you use doesn't matter, because both of the methods lead you to the same destination, that being the correct answer.